Now that we've got everybody in the room, I'd like to take the time to welcome everybody to Snowflake Office Hours. My name is Ross Perez, and joining me today, we're very lucky to have Paul Becotte from Narrativ. Paul spent 9 years in the U.S. Air Force, where he served 4 tours in the Persian Gulf supporting OEF, OIF, and was promoted to technical sergeant. After leaving the military, he graduated magna cum laude with a BS and MBA on the GI Bill. Paul entered the software development industry, building defense equipment at L3 Communications, and progressed to building massive distributed systems at the scale of the internet with Narrativ. He especially loves smooth processes and self-healing systems. So the format of today's presentation is relatively straightforward. Paul is going to describe Narrativ's experience using Snowflake, and then as we go through the presentation, you can be entering your questions into the Q&A box, which you can access through the bottom of your screen. At the end of Paul's presentation, I will go through and basically ask Paul the questions that you have sent to us, and we'll do our very best to get through all of the questions that you may have. We're lucky to have a lot of people on the call today, so we may not get to every question, but we'll do our best. With that, I'll turn it over to Paul, and thanks again for joining us here today, Paul.
Yeah, no problem. Thanks for having me. I'm really excited to tell you guys about our migration to Snowflake that we've done over the last couple of months. It's been a good move for us, and we've really enjoyed the process. So let's go ahead and tell you a little bit about our company. Narrativ is a machine learning platform that connects products with all of the content created about them. We do that by thinking about commerce content, and commerce content is an article that's like the 5 best sunscreens for sensitive skin, or the best headphones you can get for under $50. It's a growing percentage of the content that actually gets created on the internet, and we are doing a key role to help the publishers who create that content monetize it. We do that primarily by being able to understand the relationships between products across websites. Is this pair of shoes on Saks the same as this pair of shoes on Nordstrom? And by processing very large amounts of data related to what's going on their websites, related to clicks and customer conversions. So with all that said, let me tell you about where we were last year. So our architecture for our analytics system is pretty simple. We have an API. Events happen in the world, with an event being something like a click or a page view. They go to our API, and we dump them into Apache Storm. And from there, we would enrich the data. So say we have an IP address, we would look up the IP address and figure out the geolocation for it, as an example. Then we would turn that event into a blob of JSON, stick it in S3, and we'd use some custom code we wrote to constantly load that data into Redshift. So this all worked pretty well. We had data flowing into Redshift with about a 5-minute lag time, which wasn't too bad. And we were accomplishing most of our goals. However, there were issues as well. The biggest issue that we had was Redshift has compute and storage really tightly coupled together. So we had terabytes of data flowing into the system, and the rate of increase was always getting higher and still is. And with Redshift, each compute node also has a fixed amount of storage that goes along with it. So last summer, we were already up to a 40-node Redshift cluster, which gave us enough storage to hold our last 3 months of data. In order to have all of the other data still available, we'd actually written a tool that could unload data from Redshift, turn it into Parquet files, and build it into an external schema. So because Redshift allows external schemas, we could still have sort of a hot and a cold storage, and we could write queries that would hit both at the same time. So if you wanted to get stats for the last 6 months, you could do a union all between the hot tables and the cold tables. And it works, but it was still sort of expensive. Any query that was hitting the cold storage was much slower than queries that done just against the warm storage. And we constantly had to do maintenance work to unload data because Redshift also performs worse as you get closer to your data limits. So by the end of month 4, we'd already have degraded query performance because we had to go in there and unload another month of data to S3. So how did we approach the problem? We wound up going with Snowflake. And the key benefit that Snowflake offers is the true separation of storage and compute. The storage in Snowflake is completely abstracted. You put all your data in there and the system deals with it. And you pay, I don't remember the exact price, but a very small number for storing terabytes of data on a year. It's basically insignificant compared to the compute we use. And then we can have different usages of compute for different tasks. One issue with Redshift that we needed performance for was we always had a query running at all times to keep the trickle loading going and to keep our auction system up to date with the most recent stats. The performance of those queries wasn't important, but it meant that we could never shut the cluster down. We needed that to be running 24/7. On the other hand, we did have queries that were performance intensive. If somebody wanted to run a query against our analytics system, we needed to be able to return within 15 seconds or so that the query doesn't time out on the web page. Those two sort of competing issues were really hard to deal with in Redshift, but in Snowflake, it's actually quite simple. You can stand up a warehouse, which is the Snowflake term for it, and we run all of our, we run all of our steady state stuff against an extra small warehouse. So all of our analytics, our ETL jobs, our aggregations, those just run in the background because they run on a timer, and when they finish, they finish. It's no big deal. In addition to that, we have a large. So when somebody does issue a query to our warehouse, the large warehouse spins up. It can use much more compute resources to get the interactive response that the user needs, which was amazing. You can go into Looker, and it will, within a minute, the warehouse will come up, the Looker query runs, and if nobody's using it, it shuts down, usually for 6 or 7 hours a night. We only have the one extra small warehouse running. This solved the problem pretty strictly, and it didn't have the pain points that we were expecting. It wound up being very nearly a drop-in replacement in our Python code base. There's a SQL Alchemy dialect, so we didn't have to do any customization there. It's just built right into our Flask SQL Alchemy application. Snowflake now offers built-in trickle loading, which they call snowpipes, which you set up a little bit of extra stuff in your schema, and it will automatically ingest new JSON files as they appear in S3, which we'd had to run infrastructure to do ourselves for the last several years. And being able to scale up and scale down without having to worry about how many hours it was going to take to reboot the Redshift cluster has been a huge relief to our operational load. So how hard was it is the real question. A year before that, we've gone through a bake-off of Redshift, BigQuery, and Elasticsearch. We found that Redshift was the slowest of the three, with Elasticsearch being the fastest, but there was a lot of pain involved moving the data around, getting it into those systems so that we could test it and run sample queries against it. And it wasn't really a realistic test of those things. A test BigQuery system that you run some sample queries on is very different from having it in production with your analytics database hitting it however many times a day. That was also an issue that was really hard to understand how much it would cost to use BigQuery for this because they charge on a per query basis. But when we went to test Snowflake, I was actually able to load all of our test files that I had created for the BigQuery tests into Snowflake on that first call within the half-hour call, and we were running the sample queries during the sales call. I really liked that, so we set up a second sales call, and we got the trickle loading working in that sales call, which meant that we had our production data streaming in real time into Snowflake with less than an hour of engineering work and just a single person, which is why we decided to go ahead and do the full integration. After we signed up, the biggest chunk of work related to this was we wrote some code that would work with our Alembic migrations. Alembic is a Python tool for doing database migrations and keeping track of the state of the database. So when you want to add a new table or whatever migration you want to do, it knows how to go from state A to state B and keep the application talking to the right version of the database. So I wrote a level of code that sits on top of that every time you add a table, it will set up the trickle loading things, which is a simple notification service on S3 and a couple configurations in Snowflake. So now I don't have to worry about anybody on the team making sure to set it up individually. Every time they add a table or delete a table or change columns, that's all taken care of. So the trickle loading continues to work. And I did publish a blog post about how we set that up with sample code if anybody is using Python and interested. Then we had to go and find all of the places in our code base in Looker that had raw SQL because there was a few differences. The main one being that date is a function in Redshift and it's just a type in Snowflake. The updated syntax works on Redshift as well, as we use the version that Snowflake didn't support. So we had to fix that in some places. And finally, we had some data unload tasks where customers got data dumps on a daily basis, and we just implemented that by running a query against Redshift with an unload command. And the syntax to unload to S3 in Snowflake is very different from the Redshift version. However, the Snowflake version also offers the ability to unload the data in quite a few formats. For example, you can unload directly to Parquet from Snowflake, which would have saved us a ton of time a year ago. The last thing was Redshift supports an obscure query syntax, select into, which Snowflake didn't, but it was pretty straightforward to replace those with create table as constructs. But once we got all that done, the total engineering investment was about 3 weeks of work altogether. It took us like 4 months because we did the initial batch of work and it was fine and we got around to it. There was more pressing priorities, but the amount of work was very surprising. I expected it to be harder to do the transition than it actually wound up being. Once it was all in there, our warehousing costs are down by 30%. Our queries are actually performing faster than they were previously, spending more money. We were able to remove all of the database loading infrastructure and get even improved load times. So less maintenance on the engineering team, less compute costs on AWS, and the data is 2 minutes behind instead of 5 minutes behind. Not that that's a big difference. When we deployed, we found out that New Relic monitoring wasn't working properly with Snowflake, but New Relic got that fixed for us. And it did take us some time to figure out the best setup in regards to number and size of warehouses. We did blow through a lot of credits experimenting and trying to figure out the best way to handle things with there. But overall, the whole project was a huge success and win for us. And it's the smoothest major infrastructure change out that I've personally been a piece of. Usually changing out a key component like a database is very painful, but it went very, very smoothly for us. So that is the whole spiel. I guess this is the time for questions.
Awesome. So just as a quick reminder to everybody on the call, if you have a question, please enter into the Q&A box which you can access through the bottom of your screen. And then we will periodically go through all of the questions and continue to answer them as we go along. All right, so Paul, we've got a lot of questions in here. One of them you've kind of already talked to, but just in case you have some additional insight into this. Somebody's curious what the best way is to migrate an existing on-prem data warehouse into Snowflake. Do you, looking back on your migration into Snowflake, is there anything that you think would have been different if you were coming from an on-prem environment that you might want to look out for? Sorry to put you on the spot for something that you haven't done, but I figured you're pretty knowledgeable. It might be worth asking you the question.
Well, so it would depend on how you're loading the data. Assuming that there's a way to export a known state from your data warehouse, the way I would set that up is whatever you have streaming data into the warehouse, I would set it up to stream into S3 in parallel, or Google Cloud Storage, or whatever you wanted to use for that, so that there is a data source that Snowflake can read from that's getting new data, and then I would do an export of the data from the old warehouse and ingest that into Snowflake. So now Snowflake is up to date with the same data, and you can switch systems over to point to it as makes sense.
Yeah, that absolutely makes sense. So a bunch of questions here about Python and how you're using Python with Snowflake. So I'm going to ask all three of these together, and I think they should be pretty easy to answer in the same breath. So are you able to run the Python code directly on Snowflake? Are you getting data into Python using a connector and running the Python code? And then can you please share the sample Python code that you mentioned? And actually, Paul, we can come back around to that at the end if you want to just kind of answer the first two parts of the question.
Yeah, sure. The third one's actually the easiest. If you go to blog.narrativ.com, you can see the blog post I referred to with samples. But yes, we're using Python directly on the Snowflake warehouse. So we use SQL Alchemy, which is a database connection layer that I highly recommend if you have no experience with it. I haven't seen anything at that level of quality in any other programming language. I think it's probably the best suite of database tools. And once you set up the Snowflake dialect versus a Postgres dialect or whatever else you may be using, it just works like any other database would.
That makes sense. Does Snowflake have workload management rules similar to Redshift to kill any bad queries, or did you build, sorry, I'm having to click on this, or did you build any custom workload management rules?
We haven't gotten into workflow management yet. Most of our ongoing important queries are in the background process, and we know that those don't interfere with each other yet. And then the interactive ones where people can set up whatever they want through Looker, or the analytics, or our web app. I'm guessing that at some point we'll figure out a way to bottleneck the system, but we haven't actually seen any queuing or interference between queries yet. So fingers crossed, it hasn't been much of an issue for us.
That's good to hear. So you said that Snowflake was faster than your previous solution. What type of queries or processing do you normally do?
Yeah, the vast majority of our queries are stuff like how many click, or sum up the value of all the clicks where the user fit into these three categories, and it happened on this particular publisher website. So it's a lot of aggregations and counts and window functions. And the simplest thing we do is associating click and checkout events, and we use window functions to do that because a checkout and a click have to happen within a certain period of time. And we use the complicated window functions in a background process to continuously update an aggregation table that we use to serve our web app. And that responds in milliseconds. And these background queries actually improved by almost 50% because it seems like Snowflake's Query Planner handles window functions and aggregations better than Redshift did. We did notice that some types of queries it does significantly worse on, like doing select a single row where ID equals whatever. If you want to look up a specific row of data, that is much slower in Snowflake than it was in Redshift. Of course, we never actually do those queries for any of our production systems, so it hasn't been an issue, but it was kind of until we figured out that was something we shouldn't do while we were playing around with it. We're like, why does this query take 10 times as long as this one?
Yeah, that makes sense. Lots of questions here related to data ingestion. I'm going to read them all, but I think they all are related here, so should be easy to answer together. Are you using any ETL tool with Snowflake? What data ingestion tools did you use to ingest the data into Snowflake? Did you or have you considered using Snowpipe instead of a dedicated warehouse for ETL?
Yeah, Snowpipe is actually what we're using. The ETL stuff I refer to is background aggregations. So we didn't build any ETL stuff. We're just using Snowpipe. The whole process is we use an external system to create the data in JSON files. We're using Apache Storm, but there's lots of choices. They would all work the same. We put the JSON files that we want into S3, and we let the Snowpipe feature take it from there.
Okay, and then this one is also somewhat related. So using trickle loading, how would sudden changes in incoming schema get handled? Specifically, for example, when switching API endpoints, so the schema change is expected but potentially needs to be mapped after the data has come in. So it's a little specific, but if you can try to answer that one.
No, yeah, so with Snowpipe, when you're configuring it, you have to basically tell it how to map the JSON file to columns in a table. And there's also the option you can just ingest it as JSON, which would be fine. But we wanted the better performance of actually having columns. So the Snowpipe configuration depends on the shape of the incoming data. So when we do a database migration, when we add a new column, the code that we referenced in that blog post automatically updates the Snowpipe ingestion to expect that new column. And we do it as a policy that a new column is always optional because the API doesn't have that new field yet. So we add the new column to the database, then we update the API to actually populate the new column. And if we really need to, we can go back and make that new column mandatory or non-nullable later, depending on how it goes. But as long as you make changes in an additive way and remember to update the Snowpipe config along with the database table schema, it's quite easy to do.
And it's awesome that you guys are taking advantage of Snowpipe to load data, and it seems like you've really developed a good system for that. And there's a question here about whether or not you're using Snowflake's automatic clustering feature, if you're clustering at all, if you see any performance improvements there. And it would be great, too, just to hear your thoughts on kind of these services that Snowflake is developing to try to automate, whether a lot of the processes that you're taking care of in the data warehouse, from data loading to clustering to materialized views and whatnot.
Yeah, the data loading was a really neat feature. The fact that it's just built into the database was pretty amazing, and probably a big reason why they got the business. When it comes to materialized views, I wasn't aware they were working on it. I actually think somebody mentioned it, but that would be amazing for a data warehouse to do as well. I'd like to see that.
Yeah, and the question was also getting at clustering and whether or not you use Snowflake's functionality there.
Yeah, I know I lost track of part of it.
Yes, sorry, I added a lot to that question.
I appreciate it. We are using Snowflake's built-in clustering. We thought that we might be able to do better, and we did try a couple times, but we weren't able to actually improve performance much on it. Like I said, most of our data is the timestamp is the most important column in most of our data for the purposes of querying, and Snowflake seems to do a fine job of understanding that and the query planner handling it without too much interference from us.
Yeah, that's good to hear, because I think, from a high level, the idea from Snowflake, with Snowflake in the beginning, was that it would kind of take care of all of the tuning and optimization that you would need, and clustering is really one of those few areas where it's difficult for us to predict the best way for, or to choose the best way automatically. So sometimes clustering will help, and sometimes it won't, which is actually in some ways a good thing. So what's your user audience for Snowflake, and is your web app connected to Snowflake?
Our web app is connected to Snowflake, so our entire customer base will be the user audience. So we have a web app that uses Snowflake, and we have done some pre-aggregation to keep that running snappy, and most of those queries are finished in much less than a second. We also have Looker hooked up to it, which is a business intelligence tool, and our sales team, our analysis team, they can go in there and do other queries that we haven't thought of yet, so they can do their own, which can get kind of complicated depending on how well they understand SQL. And then on top of that, we have the engineers ourselves who generally have open SQL terminals and the ability to just to run their own completely arbitrary SQL commands. So the kind of 3 tiers of users are set up that way.
All right. How many warehouses did you create? And I assume there they mean how many virtual warehouses did you create? How did you determine the resources, the compute and storage of the warehouses? And did you apply any real mathematical formula to determine this warehouse size? And I think I'll just kind of half answer this question, make it a little easier on you. One thing to know with Snowflake is that the virtual warehouses are actually not storing data besides the cached result of executed queries. So the data that's actually being stored in Snowflake is in the back end being stored in S3, which means that the virtual warehouses that you're creating don't need to be sized to the amount of data you're bringing in. But Paul, what I'd love you to talk about is how you thought about warehouse creation. You were talking about your user audience, so I'm sure that's, since you have so many different groups, that kind of built into it. And then as far as sizing of the warehouses too, that's kind of an interesting topic that I'm sure you have some thoughts on.
Yeah, that was kind of one of the things that we struggled with a little bit. When we sat down to do this, we went overboard. So we had our warehouse to do our pre-aggregation on the data. We had a warehouse to do the loading, which we didn't realize we didn't need at all. We had another warehouse for time tasks, and we had a staging warehouse for our web app and a release web app warehouse for our web app and a Looker warehouse. And we set all that stuff up. We picked random sizes, and we went with it. Turns out that wasn't really the right way to do it, and we were able to consolidate down to 2 warehouses. So the first issue is that there's really no permissions issues with warehouses. So our staging environment, for example, very rarely has heavy queries running on it. So the permissions issue where you don't want to give staging access to production or vice versa, they were able to share compute without any impact back and forth. So reducing those. And then our Looker warehouse and our web app warehouse are doing the same exact thing, where the only concern would be if the queries from one was interfering with the other. We were able to consolidate them, and we haven't seen any interaction between them at all. The way we have things configured right now, we have one warehouse running for interactive queries in every environment and every system, and one warehouse running for everything else. And the everything else warehouse is actually an extra small that runs 24/7. And the interactive warehouse comes up when one of the systems is trying to use it. The databases themselves are much more broken out. So we used roles to make sure that access to the data was restricted based on the users and the roles, But the warehouse itself, the compute resources, we were able to share, or so far we've been able to share pretty efficiently.
Yeah, and that's kind of an interesting point on choosing and designing your Snowflake instance, because you have a lot of flexibility with the number of warehouses you can create, but that doesn't necessarily mean that you need to go out and create 20 different virtual warehouses for every single use case, and it sounds like that's been your experience.
Yeah, I mean, so like when we finished the integration, it's like, all right, let's look how much we're spending and make sure this is under control. We found out that all of the warehouse we'd set up were running one query at most concurrently, where it's just not a particularly good use of a data warehouse. So combining all those resources into much fewer warehouses so that we can use some of the concurrency capabilities, there was no impact on performance so far at all. And the price I think we spending about 15% per day of what we were when we first did the switch over.
Right. That makes sense. So somebody's asking if fully denormalized tables are better, or joining multiple tables at runtime for quicker query execution time within Snowflake.
We've done both. For analytics warehouses, my experience is that denormalizing the tables generally leads to better results, as long as you can do that efficiently. And most of our heavy lifting we do with it denormalized. We denormalize it as part of our data pipeline before we ingest it into Snowflake. But there are cases where that's not true, and one of the things we set up is replication using stitched data from our MySQL database that we use for facts, and we replicate that into a separate schema in Snowflake, so that the analytics queries that we want to do, or ad hoc queries, we can actually use those, join against those tables for whatever we need. So for analytics type stuff, interactive, like ad hoc queries, normalized tables make a lot of sense. But for the things that we do a lot of all the time, like the API endpoints from our web app, all that data is denormalized.
Right. How many Snowflake accounts do you own to manage the dev, QA, and prod environment at Narrativ?
We have one account. I mean, we're a 16-person engineering team, so at this point we try not to break things up too much.
And so do you utilize features like zero-copy cloning to do your dev, QA, and prod, or what's your kind of thought process behind that?
So what we do is we have an isolated environment for production and an isolated environment for QA and staging, and we don't copy data between them. So we have fake systems to generate data for the test environments. So we run load tests constantly against our staging environment, and we insert extra data for specific tests to make sure that if the data looks this way, this query returns the results we expect. And we use roles in the Snowflake configuration to make sure that the web app and the users in the test environment can access any of the data in the production environment and vice versa.
Right. What's the user volume of your web app on a daily or weekly basis?
I think we're about 500 daily users. So our users we're a B2B company. So publishers or editors from publisher applications, or we work with merchants. So the ad spend teams from the advertisers will log into the web app and be able to see their performance.
Great. So somebody is also wondering if you can comment on how they can do recursive joins with a parent-child relationship.
I haven't tried it yet. I don't actually even know if it's possible. I just found out you could do it in Postgres recently, so I'd love to hear the answer to that.
Yeah, I unfortunately actually don't know the answer to that one either, so we might have to loop back around to that. But thank you for at least talking to it a little bit. So this is the last question
like a poor model. I was just about to say, it seems like a poor model for a columnar database in that case as well. So it might not be the right tool for the job, even if it can do it.
Yes, good point. All right, so this is the last question we have currently. So if you do have any questions, please feel free to continue entering them so we can get around to them. Do you have any documentation of the technical design of your data warehouse?
Yes, we have internal documentation, but nothing that we've shared publicly. But that might be a good opportunity to add some more writing to our blog.
Yeah, I'm sure there'd be lots of people that would be interested, at least at a high level, in how you set about doing things and organizing everything that you're doing with Snowflake. Okay, Paul. So that's kind of the end of the line as far as the questions are concerned, and it doesn't look like we're getting any new ones. So I think we can call this office hours a great success. And I just wanted to thank everybody for attending, and Paul, especially to you for giving us your time today. We really appreciate it.
Yeah, thanks. It was great being here. I enjoyed it.